I'm gonna show the discussion on the Oracle. Let's talk about what happened. We missed a bug on our tester, the contract that we were using. Yeah, so this is basically the contract we had. It's called the Echidna price feed tester. And so this was our invariant tester for Badger. And we'll go over some of the problems with this, but fundamentally, this is the bug that was found. And it was that fetch price can return a different price in the same transaction. And there's a specific edge case here, which is that once Chainlink ends up returning a price above 50% from its previous round, so obviously it's highly unlikely, but once Chainlink has that 50% deviation, it's going to trigger a fallback case, but because we were expecting to not have a fallback oracle, then what's going to happen is that the first time that you call the oracle to read the price, you're going to get the last good price. And then the second time, because we have no fallback caller, and because we added this condition that basically says that if there's no fallback caller, you can trust Chainlink again, then that will make it so that on the first call, you will get the old price, which will be considered the safe price. And then on the second call, you will get the Chainlink 50% changed price. And so that means that this would have allowed, obviously in an extremely unlikely scenario, but in that specific scenario, it would have allowed a 50% arbitrage. So it would have been a pretty severe problem. And I'm not sure how familiar you are with the Liquidity code base, but the Oracle from Badger is basically the Liquidity one, with the difference that we expected the fallback caller. We basically replaced the teller caller with the fallback caller, and we basically expected not to need to use it. And then through various audits, such as the Spearbit audit, we had discussions about what would happen in that case. And so this is an example of adding this innocent change and then not fully thinking about the consequences of it. So it's interesting how the latest design for eBTC actually uses a completely different design where it basically checks Chainlink. If it works, it uses that. If it doesn't work, it's going to use a fallback. But it's a lot more simplified because at the end of the day, having to maintain 700 lines for an Oracle is basically not great. And so this is the contract as is. I'm going to literally go through what I did. And I want you to notice something. So I'm going to undo a fix. And this is literally, I downloaded the repo from the C4 contest. And I'm going to go on contracts, on the contracts folder. So that's how you can run it. So for the sake of the demo, I'm actually going to use a terminal because that way it's going to be a bit easier to see. So from the eBTC root folder, I just cd into packages contracts, and then I'm going to run, and something I've altered is the medusa.json file. I basically changed it to use the Echidna price feed tester. So, but that's literally all I did. I'm on the branch called, there's a lot of branches. I'm on the branch called 0.5, and all I did is I changed the medusa.json and the foundry so that it compiles. And now I'm going to run Medusa, and what you're going to see is that it's going to fail. And I think it's really important that I show this, right? Because at the time, and obviously I'm shilling my own product, I'm shilling Recon, but at the time, it wasn't that convenient. This was back in October, November. It wasn't that convenient to run Medusa locally, nor it was, and it still is extremely inconvenient to run Echidna locally. And so we had Antonio set up a CI/CD system, and that was the only way that, through which we were able to test our contracts. And so I want you to think about the fact that you can spend, a lot of time setting up something, but if you don't end up using it and you don't end up trying it, this is actually what happened. And so this is a clear indicator of the fact that none of us had spent a sufficient amount of time in checking the handler, because as you can see, it's literally impossible to even run it. And that's because Medusa, when Medusa runs, it starts from block 0. And so if you do a block minus, you're going to get a revert on the constructor. And so that's what I did here. I just changed all of the values from block.timestamp, etc., to just 1010 so that we get a compilation. And so we're gonna actually get a compilation in this case, but for the sake of speed, I also had already gotten a log. And so this is really the first aspect. This is why what I showed before with the sharing is so relevant, is because this is what you have to do. You really just have to let Medusa run, let the fuzzer run, and then see how it goes. It's really important that you do that. And so let's check what our coverage report looks like. And so this is the coverage report. Hopefully this is not new to you, but at the end of the day, when a line is green, it means that it's been covered. When a line is red, it means that it's not being covered, which means that it's not being called. The fact that something is green doesn't mean that all of the possible combinations have been tried. It simply means that a combination was tried and it didn't cause a revert. And so as I scroll down obviously the first thing we want to do is check the number, just think about the only contract that matters, which is the price feed. And so let's just go until we find some red, right? And so now, and maybe I'll put this in the slides, but you can see that we have red on the fallback being frozen. We have red on the fallback being frozen and then the fallback not being broken. So we have red in this scenario. We have red in our chainlink price above max, you see, and that's because you can see this is a very important distinction in how you interpret the red and the green lines. But this green line at the top means that the check is being performed, meaning that Chainlink is working and Chainlink is returning true values that are not greater than 50%. And so we never get to this point of both Oracle and trusted. And so now obviously we know what the bug is. So we know that that's the scenario that we're looking for. But as a invariant developer, as a developer checking my coverage, well, this is telling me that that statement is never evaluating to true. So that's really important to keep in mind, and that's going to be one of our goals. We also have that the oracles never have the same price. We have that we're using we basically never have true for the case in which we are using the fallback and Chainlink is untrusted. And that's because this line is being evaluated, but this line is always red. So again, that's another interesting aspect, and we'll see how deep this set of issues goes. But at the end of the day, we're not checking all of the statuses. We are not reaching that coverage. So the question is, how do we do that? Well, we're gonna go in the code. We're gonna make sure that we can run, right? We know we can run Medusa. So this is basically going to be our setup. And so this presentation will go from a presentation to a workshop now, where I'm actually going to show you what I'm going to code in order to solve it. And for the sake of time, we'll eventually cut it short, but I'm basically going to go through the steps. And so the steps are going to be changing the Echidna price feed tester, then going in the Medusa folder, checking the coverage report, and basically getting that report to give us a higher level of coverage. So that's basically the precondition. And the interesting aspect is that I showed you the symptom, right? These are the symptoms. This is the lack of coverage in the actual contract. So this is the most important aspect, but because of how the coverage report works, we can actually look for the cause. And so our next step in evaluating what's going on will be to go and find the coverage for the Echidna price feed tester, which I believe I scrolled to. I think it's this one. Fallback Echidna price feed tester. There we go. We got 89% on this Echidna price feed tester. And so there's many things that we have to look into. And perhaps as I scroll, maybe if you watch the other video, you already know what the answer is. But as I scroll, maybe can any of you point me to something that looks a little bit off? We see some messages here. We see some red here. But if you look at this, it's kind of hard to tell that there's anything deeply wrong with this system, right? And yet we know that our coverage is wrong. So there's no clear issue here, but there's definitely an issue on the other end. So anybody willing to take a guess on what's a couple of low-hanging fruits here of things that are wrong? Ideally that you haven't already watched the other video. So yeah, if you guys can share the report for the eBTC contest, it's in the Code Arena repo. So, but the short answer is that we have a scenario of a 50% price change. I don't think I'm saying anything particularly weird here. 50% price change, but our line here says that the maximum price change is 20%. So this is like, if you can imagine having a low-hanging fruit, I think that will be it. Like if there's the lowest hanging fruit possible is the fact that our code will work. You can see that it's green, which means that there are no weird reverts. We don't have the code written extremely poorly. However, our maximum price change is 20%. So we have unwillingly created this red line by setting this green line here. And so the first thing I did back in the day was to actually change this to 5 and just let, or maybe you would change it to something like, 20 or 50, not because I want that as my final result, but simply because, again, I'm just trying to understand if I'm directly influencing the coverage through that value. And so this is us almost treating the system as a black box where we set this value, we want to check it, we see 40, we used to see 39, so my brain is immediately thinking about something else. I'm seeing 0, so some property may have been broken and we're in the shrinking phase of Medusa. That's typically what happens. And so we see the price feed must never revert. So now in setting this max price change, we're starting to get some more interesting scenarios. Obviously, this could be a complete gibberish, completely random thing. But at the same time, we are at 40 when we were at 39 previously. So obviously, we ran the fuzzer for 1 minute. Maybe we'll let it cook for a couple of minutes. But at the same time, as I think about this change, perhaps the next step will be to simply use the search function to go through all of my values. And what I'm going to start looking into is really this clamp between. You see, we have set, fallback, response, answer, timestamp, bool. So what does this mean? This means that our fallback oracle, which we can go and check the definition, but at the end of the day, all of these contracts are basically just you set the value and they return that value. There really is no particular logic. And yet, our current logic is saying that the price change can only decrease by I guess a percentage here. So it's going to be clamped in this way. And then the alternative is that we're going to get the answer and we're going to multiply it by the maximum price change. And so this is something that, and there's going to be more issue, but this is something that you want to think about, is whether it's a good idea to have a percentage change at all. So what I can do here is perhaps I'll just stop to see if this extra point of coverage is the point of coverage we needed. So on the left, we're going to have Echidna price feed tester at 80-90%. Here we're going to have Echidna price feed tester at 90%. So we have one extra line. So let's go and see, I guess, what the line is. Most likely it's going to be the revert here, right? Because we were able to get a revert. So we basically got this scenario here where we're getting a revert. And so this is another thing that sounds completely random, but it's something that if you really think about it, if you look at just these lines, something that I know because we've been thinking about it is the idea of a contract self-destructing. And so something you want to keep in mind is that Medusa and Echidna will not fail on a revert. They will simply skip the call. And so something that I'm immediately seeing here is that the fetch price function is calling get fallback response. And so something we should go and check on get fallback response. So I'm just gonna get fallback response with an N in the front, so we only find the function definitions. Mock fallback. So something that I want to look into is this: get fallback response will revert if the fallback is set to revert. And it will also, we also know, because again, we had these ideas, we also know that we can set the fallback color to the address 0. So again, does anybody want to take a guess as to what I'm thinking here? Again, we have a possibly non-existent contract, or we have a contract that reverts in our test. So what do you think is happening here that we're not necessarily seeing in the coverage, but we should think about because of what we know about the fuzzer not reverting and the fuzzer instead skipping these calls? Anybody want to take a guess? What happens when you call a contract that doesn't exist? I think it's pretty, you know, I made it a bit too easy. And so the call will revert. And so what that means is that we have a test for a call reverting here that is actually being skipped every time the fallback caller doesn't exist. And the fallback caller will not exist in many cases. So the best way to test that is to go into fetch price, and basically let's just add a if fallback caller equals to 0, then let's just assert with message false, and let's assert fallback is unset, or we can just assert it would cause a throw or a revert, right? So we know that fallback caller could be 0, so we expect this to be hit fairly fast. Let's see, we got, yeah, we just have to do address. So we run Medusa again, and again, what we're doing is we're slowly increasing on our understanding of the system. We're slowly increasing the agency that we have over the system, because again, if I'm wrong, then that will not revert, and that's fine. However, if I'm right and the fallback caller is being set to the address 0, then this line will be hit. And so there's two considerations here. One consideration is that fallback caller maybe is never 0, and so that means that our handler that is setting this fallback caller is actually not working. That could be one. And the other one is that instead the fallback caller, or I guess we're never changing this address to the fallback caller. So this is something else that we can go and check, will be to see that fallback caller is there, is set here in the constructor, and then it seems like it never necessarily changes, but we can see here price feed dot set fallback caller blah blah blah, right? So what are the odds that this is never called, right? What are the odds that this is always reverting? Well, again, we could go and do the same thing where we just assert false here, fallback caller has been set to something, and I think we have the assertion library here, so I can use T. And so this is where I guess we don't have that, so we'll use assert with message. Again, now we have an assertion that is helping us determine what's going on here. And what we're going to find is that something, I mean, maybe I'm wrong, maybe we actually unsaid it, but what I believe we're going to find is that the system is actually not really trying a lot of combinations because of that value. So we will let Medusa cook a little bit, but at the end of the day, now we have a hunch over something that is happening. What hunches do we have? We have many, but one of them is, so I'll just do an @audit tag. Hunch 1 is gonna be that this is never unset. So governance is off. That could be a question, right? And then the version 2 of this is that we set the fallback, was it set fallback caller, and this is never reverting. So this is never reverting. So that's where I will want to zoom in. Obviously, our real goal is to get coverage at the 50% mark. So we basically are on a side quest here. And yet the side quest is giving us insights into the state of the system. So as I let Medusa cook, because maybe I'm wrong, so there's no point for me to stop Medusa at this point. Let's let it cook, let's see what happens. But at the same time, I'm gonna go in the coverage and go and check this set fallback color on the mock price feed. So I'm gonna go on mock price or price feed mock. And I'm going on the price feed and I'm checking set fallback color. You can see that my tester has green, so it is trying this, and yet it is red here. So what's going on? The answer is in this little modifier requires off. So at this point, I think I made it clear that we've identified that there was code that was seemingly doing something, and yet once we dug deep enough, we ended up realizing that it actually is not doing anything. So what does this require off look like? I guess it's in a off no owner function. I honestly don't remember, but basically we're getting the green line on is authorized, and then we're most likely getting this to fail. So what could you do if you wanted to baby step this? Would be to put an assert here on line 18. You will put an assert and you will enforce that this works sometime. And instead, the way we're going to do it, because I've already done it, is to go and check what the authority looks like. And so we can see here, we have, authority set here. So let's go and see what authority is. Authority is off no owner. And so this is where things become a bit complicated. But at the end of the day, for some reason that, again, is simply because of a lack of spending time, the authority of our oracle, so our oracle is price feed, constructor, blah, 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 authority address. Our authority is actually, for some reason, a contract that is the authority. So instead of setting an actual governance, instead of setting a mock governance, instead of setting something that would work, we actually have this pretty odd solution of this off no owner contract, which I'm not exactly sure how we would even use it as the authority of the contract in question. And so what we have to do, because price feed will basically initialize the authority. So let's see how that works. Initialize authority by getting the address, setting it here, and then it's gonna just store it, I'm assuming, in storage as this thing. So what we want, and basically then what it's gonna do is it's gonna cache it locally into this, I guess, memory, and then it's gonna just perform a call by getting these values and returning true or false. And so you can see, by the way, that a call is authorized if off must be different from address 0, and it returns true on this can call function. So when I look at this, the next step for me will be to see if we have a mock version of this. But what I'm realizing pretty quickly is that our authority is simply not set up. So we have to set it up. And you can see that an example of a mock authority will look something like this, where it's basically just a single function that returns true. And so that's exactly what I'm gonna do. I'm gonna go on Echidna price feed tester, create a new file. I'll call it the mock always true authority. I'm gonna paste this interface so I don't forget. I'm gonna grab my headers because why would I remember those? I'm gonna declare a contract here with this name, contract, Then I'm gonna grab this function signature, and then I'm gonna make it return true. So anytime this authority is called, it will always return true. But now, when we call set fallback oracle, we expect our mock authority to return true. So we expect this line to become green, or this line to return a value that allows this to actually go through. So let's see if that's the case. We just need to set it up by importing mock true authority. We're gonna declare this new mock true authority here. We're gonna set it in the price feed. We check Medusa. We see that we have a bit more coverage, but we still didn't break any of the extra properties. So we set the new authority. We get a revert. That's unfortunate. Let's see if we can debug it a little bit. Blah, blah, blah. Most likely some error here in the name of the file. Blah, blah, blah. It's not explicitly compatible to off no owner because we need an off no owner. Where? Well, I guess authority here is declared as off no owner. So let's change that as well. We really don't need it as off no owner as far as I know. I don't see why we would. So at this point, there we go. How long did that take us? Like a quarter of a second. That's how long Medusa takes to break the property once the path is allowed. If you forgot, because it takes a while, I set this flag to let us know that this call was successful. And the second we set the authority to something that returns true, we have now unlocked more coverage. So I'm gonna delete this. I'm gonna also delete the other one in fetch price, which was fetch price. You remember this one that is set to 0. So I guess we'll keep this one for now. Let's run Medusa. It's gonna take 10 seconds to compile and run, and you'll see that our coverage is actually gonna increase, potentially even dramatically, because now we are toggling between having the fallback and not having it. So at the start, we're gonna have Medusa stuck in shrinking mode, so that's why it's a 0. But now it starts to actually discover new stuff as we have allowed it to have governance perform those changes. So we'll see if it actually is able to set it to 0. We can see that it's not, this is not succeeding yet. So it could be that there's something else that is incorrect. And so that's really kind of our workflow as we slowly and methodically go through the lines as a means to ensure that they end up working. So I'm gonna try and get a little bit more coverage and a little bit more achievements in the next few minutes. But this is kind of it in terms of the process. The process is really about having educated guesses on why the coverage is not growing, and then using the report as a means to detail that. And so any other trick, which could be, you know, emitting an event or having asserts, is really convenient, really useful. But at the same time, they're basically an extension of figuring out where the tool is and figuring out whether it's moving where we want it to go. So we can definitely tell that this is actually incorrect because of me and not because of the setup. So the actual test should be that the price feed dot fallback caller. So let's see what the price feed variable is called. Fallback caller. So that one needs to be set to 0. So that was my mistake instead of on how I implemented the property. And what's interesting here of what I did is I stopped Medusa. I'm gonna rerun it, and this is basically my workflow. I just stopped it, rerun it. I'm gonna go back to the coverage report, refresh it because it's a new file now. It's gonna get the new pointer to the new file. And so we can compare this one, which was the really old one, 89% to 93%, right? Inch by painstaking inch, we are getting a little bit of a better coverage. And so as I, you know, open up my mind about the idea that we, first of all, we didn't find the bug, so I would, you know, shit my pants. And so the next step of what I will do is I will see if we can get this revert, and we can see that we get it. You see, it will cause a revert. So now we know that this test is written incorrectly, because this test that is supposed to catch a revert can actually revert without catching the revert, if that makes sense. So something you could do, which I think is hilarious, will be to have like a try catch against this. So you call it externally and you check. Let's do it just for the for fun of it. I guess fetch YOLO public. I don't remember what log is, but basically we will just do a try this dot fetch price, and then we would catch, and then we will move our assertion here. It should never revert we actually catch it to here, although it's technically incorrect. But now we have created a function that will flag this revert without, it basically is evaluating the quality of that test without necessarily causing more issues. And so going back to our 50%, or rather our test on the price, our test will be function ensure double test, or ensure price cannot change in same block. Beautiful naming convention, right? You can just call it frob if you prefer. So we basically will end up doing a fetch price on this, on the price feed. And so let's just do it the non-reverting way for now. And we will literally just grab price true, and we will then assert EQ on price 1 and price true. And so something you want to keep in mind is that this will revert in many cases and it's going to be skipped. But at the same time, this will be a simple price check. And so now we have that going. We have our coverage growing a little bit, as most likely we are letting more reverts being caught. So the growth of the coverage doesn't necessarily give us additional information, whereas this property right here definitely now gives us a level of confidence that we're at least trying to prevent the potential exploit or the potential risk. And so this is where we would let Medusa cook a little bit longer, maybe 5 minutes, maybe 10 minutes, maybe 2 hours. And we will want to then reassess again whether our entire methodology is incorrect, which I believe it is, but you will have a bigger benefit in letting Medusa run for a bit now, rather than just jumping to more work and more conclusions. And that's because we don't know what the coverage is if we let it run for long enough. And so it doesn't make sense to, again, jump to those conclusions. And that's something that Antonio has told me as well. It's that, if you run it locally for 20 minutes, an hour, you may find something. But if you let it run for 24 hours, you may find something else. And so this is not indicative of the fact that the system is done, but rather these early successes are just indicative of the fact that we have created a bigger logical space for the tool to do its own work. And so as I let Medusa cook, I would start to think about some of these functions. I think there's a lot. I personally, I don't like these functions, to be quite honest, because they obfuscate. You see this flag here? It's basically obfuscating which price feed is going to be changed. So if changing one of the two price feeds were to cause a revert, we wouldn't necessarily be able to know clearly, because we will get green on one of the two, but the other one may cause it to not be green. So that's one aspect that I personally don't like, because again, it is too dense, too complicated. Instead, if everything we have is the green line, then we have to separate every line so that a line means only one thing. And so it's really important. And then the second aspect is this clamping. So let's look at it and think about it a little bit. But this is saying that the answer times 118 divided by the max price change. So the price is being set to be equal to the previous answer times 118 divided by the max price change. So that's where I would just go on Google and I would just, divide and multiply. In this case, it's 5018. So that's basically what the price change looks like. We go from that value to this value, and that doesn't necessarily indicate any specific result, but it also indicates that we are moving in a relative way, which could be negative for us. It could cause further issues. So what I ended up doing, as I show, I guess, the result of this, as I go on version 0.7 of the price feed, is that I ended up separating these values. So it's gonna take a moment to find Echidna, Doomsday, eBTC, price feed tester base. So this is the changed setup. So you can see that we have this max price change variable, but as far as I remember, it's no longer used. We don't use it anymore. Instead, I ended up setting the values to a maximum and a minimum. I ended up using the maximum time change to be a very simple value here, like instead of having a more complex one. I guess the developer after me ended up using the select feed function, although I wouldn't recommend it. I would keep everything separate because it's easier to debug. And then you can see that the maximum and minimum values were set to be 1 and this value, whatever this value is. And so by doing that, we are creating a scenario where all of the possible values are being tried in all of the possible combination, because these are the minimum and maximum values from the original price feed. At this time, I think it uses uint 192, so it could be slightly different. But to make a long story short, those are the steps necessary to get Medusa to try more stuff. So as I pause it one last time and I go and check the coverage, I would expect that even though we have achieved some level of a higher coverage, we may still be missing a lot of these aspects. And so one, YOLO attempt to change that will be to effectively let it use a minimum price. So I would just do something like min price and something like max price. And obviously there's a high chance this is not going to work. But what we could do here is we just set these constants to 1 and max price to whatever I set it to be here. And now we have a, we can do the same thing here. We would also need to check for this time. I'm not convinced we necessarily want to use it the way it's set up. But now we're giving ourselves a chance to again get some proper value. So this is failing because probably the type is wrong. This looks fine. Clamp between line 149. Min price, max price, price is equal to okay, this is changing it to a integer. Okay, the price is a negative, possibly negative value. So I'm just gonna cast it that way, hopefully not causing even more issues. And I guess price needs to be converted back to a int 256. So maybe we're actually introducing even more randomness now because it's gonna overflow and do whatever. But there we go. We now have opened ourselves up to this, the price feed must follow valid transition status. So maybe we have found something new. We also have the price feed must never revert. We were able to break that. So it could be, we also have this fetch YOLO that we have set up that basically we're saying that it should never revert. So we have this couple of things that are basically telling us that at least we're trying something new. And so that's really what I think is a good note to close our workshop on, is really that you want to make sure that whatever Medusa can try, you're allowing it to try. And so you wanna effectively take this trade-off between time and complexity, where if you have infinite time or you have a lot of time, then you should relax these clamping even more. Whereas if you don't have time, then you're gonna do a quick and dirty solution. But the problem with these quick and dirty solutions is that you may end up reducing the possible combinations to such a low degree that you don't end up finding anything. And so to get to a point where we would be able to reproduce the actual bug, we would have to be in a scenario where the fallback color is set to 0, first of all. So that's gonna be a set of combination that is non-trivial. And so what we could do just to ensure that we can get there will be to have a check fallback is 0. And basically we would assert with message basically the check that we already had, which was that the fallback color, or rather the price feed dot fallback color is equal to address 0. And so that will give us a more likely possibility of achieving again the specific scenario that we wanted. We can see that we do have some slightly higher coverage on the price feed. We went from 68% to 83%, and so we can slowly grind out the remaining percentages. So chainlink price above max, fallback is broken, last good price. So that's actually interesting because we got to the precondition of setting both oracles to untrusted. So this is where we just needed to give it a bit more time. Address of blah 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 is equal to address 0. So once you see that line being green, that's where I would argue that I basically cut Medusa too early. You see unset color, so we have that. So now we are most likely millions of combinations away from getting that result. So we're not a lot far away. Or at this point, all we need is for the fallback color to remain unset and for Chainlink to report two prices that cause more than a 50% deviation threshold. And so if we don't end up getting there, it may also be that we probably are doing something that is delaying us or causing more problems in terms of the clamping of time, clamping of blocks, which I have comments there. So the problem that I see with this setup here is that we could end up having a massive amount of values that are all stale, because the updated at could be stale already, and then the this thing is basically not updating it to now, it's updating it based on the previous value. So it's creating a cycle where after Chainlink loses its track, it may never get it back. So that's another consideration, something we could do there. Also, notice how the previous round still uses the stupid change that I criticized already. So let's immediately address that by getting the price changer, which was this. Let's just do the same thing on set previous, right? Because we have effectively forgotten about doing that, and then just set this to prev price. And so now we have given ourselves a lot more chances of that. So I guess that's what's called the answer. But we basically just need prev price. So just do this. And so the real question that you would ask yourself is whether it makes sense to clamp the stuff at all, right? Should we even clamp it if we introduce all of this bias? And so that's what I would ask you, is whether you believe that it should have been clamped in the first place. And many times it makes sense to clamp it, because if we don't clamp it, we basically reduce our chances of having valid price, like a sequence of valid prices, at the price of having a less likely sequence of invalid prices. And so a way of dealing with that will be to have two versions of the tester. One version that is the normal version, which could be this one, which, as you can see, finds it really hard to test for the edge cases. And then you could have an alternative version, which, by the way, you will just like write a copy-pasted variant of the function, let's call it chaos. And then you just remove all of the clamp between, so that you're like, I don't care. Let's just have it try everything. And so now you're potentially, obviously you're diluting the computational efficiency, because now you have two calls that have to be called. on 2 different targets. So there is some loss of possibilities there. But at the same time, the alternative is that by adding that randomness, you're giving yourself a bigger chance of trying a lot more random values. And so I guess tonight we're not gonna get it. We're not gonna get the, you can see the coverage rising though. Maybe we're not gonna get the property tonight, but hopefully I showed you the step-by-step logic and reasoning around reaching a higher coverage. We started tonight, I think, with 40 and we're at 59. So we have effectively almost doubled the coverage. And now we are one step closer to finding the result. From my perspective, we would have gotten this perhaps with a little bit more patience. Once it comes down to patience, then you just need to let the fuzzer cook. Just let it run for longer and it will eventually get to that result. And so one controversial piece of advice from my experience could be that sometimes you actually want to delete your corpus so that you give yourself a chance to run a new run. So that way you're not, always getting the same bugs at the beginning. Perhaps you're giving yourself something new. But at the same time, you also just want to let this run and eventually you may be able to find the broken property. Awesome. So that's it from the presentation tonight. You guys have an amazing rest of your day. Thank you for joining and check the recording. I'll see you next week.